Good afternoon, everyone. My name is Dr. Eric Toring. I'm the Senior Vice President for the American College of Veterinary Preventive Medicine, and I want to welcome you to today's webinar. The webinar today is a joint effort with our partner organizations. The ACVPM has three partner organizations: the American Association of Food Safety and Public Health Veterinarians, the National Association of Federal Veterinarians, and the U.S. Animal Health Association. So with that, it is my pleasure to introduce today's speaker. Dr. Karen Bischoff is a DVM with a Master's of Science and a Master's of Public Health. She is also a diplomate in the American Board of Veterinary Toxicology. Dr. Bischoff is currently a veterinary toxicologist at the New York State Animal Health Diagnostic Center and an associate professor of practice at Cornell University. She graduated with her bachelor's degree in animal science from the University of Wisconsin, Platteville campus. She then went on to obtain her DVM from the University of Illinois and a master's degree at Oklahoma State University while she completed a residency in toxicology. She then went on to complete a pathology residency at the University of Florida before ending up in the lovely rolling hills of upstate New York. She recently completed her MPH at Cornell. Dr. Bischoff has served on multiple committees, but of considerable note, she served as the president of the American Academy of Veterinary and Comparative Toxicology from 2011 to 2013. She is currently president-elect of the American Board of Veterinary Toxicologists and serves as a member of the AVMA's Committee on Environmental Issues representing public health. So with that, I will turn it over to our esteemed speaker, Dr. Karen Bischoff.
Hi there. Very excited to be here. I've already kind of given some warning that you might have to get the shepherd's crook out on me. I tend to have a habit of going a little bit over. But I've been kind of always interested a little bit in bees. Unfortunately, significant people in my life have phobias about yellow and black flying things. So I haven't been able to spend a lot of time with my friends, the bees, but I definitely come by my interest somewhat honestly. The book in the picture is The Hive and the Honeybee. This is a circa 1950s book that was one of the very few things that I was able to keep when my grandfather passed away. They let me have what I wanted from the house, a few things, and that was one of the things I absolutely grabbed to take home with me. And it's kind of interesting because the problems of honeybees have changed significantly in the last 7 years. There are a lot of things that happen now that were not even thought of back in the 50s, and I will get to some of those things. And a lot of them are due to the way that we have managed domestic honeybees in the past, 30 years or so. Okay, there we go. I do not know who John Mulaney is. I am told he is a wonderful person, and that, but I just thought that this was kind of an apropos quote because I can kind of relate it to our little friends pretty easily. I've had a very long day. I'm very small and I have no money. So you can imagine the kind of stress I'm under. And that's really what it comes down to with these guys. Everybody's in veterinary medicine, everybody's in public health. I think everybody can kind of understand how much stress impacts health, be it humans, domestic animals, wildlife, and in this case, bees. So, which are both wildlife and domestic animals, depending. So they are important pollinators. Honeybees are a major force of pollination in agriculture, but they're not the only pollinators. There are lots of native bees, not as many as there used to be. Many of them are on the endangered species list actually at this point, but there are many, many different species of native bees, wild bees. Birds can be pollinators. Other insects can be pollinators. Bats can be pollinators. There was even a recent paper suggesting that frogs can be pollinators. So a lot of different species are absolutely necessary. Is the sound working?
You're coming through loud and clear.
Okay, because somebody in the chat has a problem. So hopefully you can work that out. So I'm just going to put this up here. I don't really have a way of quizzing the audience. It's kind of fun in person, and I know that there's electronic ways of doing it, but it's too hard. So, what is the annual global value of pollination services provided by honeybees? And I'll give you a few seconds to think it over. Is it $200 or more? I guess, I mean, the plus means you could answer any of the above, but just choose the closest ballpark. So $200, $2,000, $200,000, I should say, $200 million or $200 billion. And I actually am getting some notifications that are kind of right on target here. And it is $200 billion. That is internationally. In the United States, it's still pretty high, $11.7 billion for our honeybees and about 3.4 for our native bees. So that cha-chings up to about $15 billion. Internationally, it is much higher. And okay, just sorry, I got distracted by the chat, and I hope that that person can hear me now. So there are a lot of honeybee colonies in the US, and there are relatively few beekeepers. Most of the beekeepers out there are going to be our hobbyists, people that have a few hives that they have for personal use. A lot of friends who do that. Maybe they give honey away for holiday gifts. If anybody knows me and has some honey to give away for holiday gifts, I'm wide open. And I did see a few familiar names on the list of participants. So anyway, 150 million pounds of honey per year in the United States. That means 2 million blossoms have been pollinated by our honeybees. And it's about a $400 million industry in and of itself. But the real money is coming in from these, and so that's the hobbyist. There's sideliners who run, a few dozen and maybe sell honey at the farmers market. I think I counted 5 at our farmers market last time I was down there. And then there's the corporate ones, these big industrial honey runners that basically they aren't making honey specifically. They are there to pollinate crops. And it turns out it's the same bees that are pollinating crops across the country. So the ones that pollinate the oranges in a few, probably about this time of year in Florida, are going to be up here in the spring pollinating blueberries. In Maine, they're going to be out pollinating alfalfa later on in the Midwest, et cetera, et cetera. So it's the same bees. There's just a few paths that they take to get to where the pollination needs to happen. So interesting things about bees. There are several castes of bees, as you may recall. There's the worker bees, which is the vast majority of them. There's the drone bees. There's a few male bees. And then there's the singular queen. And how does the singular queen thing work? So according to the queen, the bee queen in this case, the honeybee queen, in the Game of Thrones, you win or you go home empty-handed. Or maybe you receive fabulous parting gifts, or you learn an important life lesson, or you just die. So I think I've gotten some people in the chat that have figured this out. So much like Cersei from Game of Thrones, the queen bee does try to prevent other queen bees from existing. So we have the hive life, and all of the bees start out as eggs, and they stay eggs for a couple days, and then the larvae hatch, and the queen's larva lasts for about 5 days. The worker larva about 6 days, and then the drones can go up, 6.5 to 7 days. But what's really interesting is when they get to the pupation stage. So the queen pupates and stays in the pupa stage for about a week, which is not very long for the most advanced bee in the colony. I mean, they always tell me, oh, the queen bee is much bigger. You can always spot her. I'm like, well, she's a little bigger but it's always the little dot of nail polish that gets my attention, to be quite honest. So she is the most advanced bee in the hive, and yet she has the shortest pupation. The workers take 12 days, and then the drones lay around as pupae for over 2 weeks. So why would this happen? Well, this is because when the queen bee decides it's time to leave the colony, or when she's, no longer functioning, the nurse bees will kind of push her towards making new queens. So she will lay multiple eggs in special areas of the hive that are specific for queen development. And then the nurses will treat those little larvae as queens, and then they'll go into the pupation stage. Well, what's really interesting is the first queen to exit the pupation stage, to hatch from her cocoon and become a queen bee, she comes out into the hive and she sings a song. And the other queen bees that are kind of scattered around the hive in their little queen cells, the other pupating queens, as they start to emerge from pupation, they hear the song and they respond, they call back. So it turns out that the queen bee is the only honeybee that does not lose her stinger when she stings. So she sings her song, call and response, the other queens respond, and then she goes and murders them because she still has her stinger, so she can murder the next one. So that's how it works. I am not making this up. This is really how they decide on the new queen. It's a little bit brutal. So again, just like that Mulaney quote, honeybee life has a lot of stressors in it. Weather, they're outdoor animals, right? Nutrition. This is the one livestock species where you can't have total control of their over nutrition. They have to forage. It's important to their life cycle. So these bees, you don't have complete control of what they eat. They can eat they can go to the place you send them and eat. They can fly off somewhere else. They can forage for miles. So we don't have total control of that. We don't have total control of our neighbors necessarily. If we have other hives that are incubating diseases, if you're a commercial hive and you're moving bees back and forth and parking next to other hives from other beekeepers, there's a potential for mixing there, although apparently the disease spread isn't as much as you might think in these situations. But also, you don't know what they're going to be landing on, whether it's an industrial area or something, you might have heavy metals, whether it's a place that was recently sprayed with pesticides of some sort. We do have some control over honeybee genetics now, but that's also going to influence their weather resistance, their resistance to parasites, et cetera, et cetera. And of course, there's the issues with pathogens. Oh, there's also wildlife. There's like bee larvae a lot. They like honey too, but they really like bee larvae. So they can break in and kill some hives. Sadistic people break in and destroy hives, all kinds of things. But the pathogens and parasites are kind of a major player, even when we're talking about toxicology. How do bees, what's in the beehive, just kind of giving some background on how these guys get along. So we talked about the different castes. There are different life stages when they cast. A worker bee starts off, she emerges, she cleans up after herself. So she's kind of the janitor at first. Then she becomes the nurse to the next bees. Eventually, as they move toward the periphery of the hive, they have HVAC bees that maintain temperatures and things like that. They have, and then at the end, they have the forager bees that actually go off into the world and bring stuff back. And that's the most, those are the older bees, and those tend to be in the most dangerous situation. There's also guard bees and all kinds of other workers, but they're all the same workers that just progress through their lifespan. And one of the things they do is they make wax. And it turns out that they will reuse the same wax over and over and over again. You can see how black the wax is. Wax is normally whitish to yellowish. As it gets older, it turns more black, so you can kind of tell how old it is. I've heard it suggested that there's probably feral bees in New York that have been reusing the same wax not necessarily the same hives. They may have come and gone, but there's probably wax from 100 years ago out in the woods in some parts of New York, just because they will come back and they will reuse it. Honey, they consume honey. Honey is carbohydrates. Honey is made out of nectar, and it's pure carbs, even though it's really delicious. So honey, and then there's bee silage. So when they bring back the pollen, they actually offload it into their cells, and then they mix it with natural flora, fungi, and bacteria, and they make their own silage. They ferment it, and then they cap it. They also make royal jelly, which is a glandular secretion, sort of like milk is for humans. The nurse bees make it and feed it to the larvae. So in this image, you see there's food stored up here. There are some empty cells with some, and you can actually make out some little eggs. So they're not all empty. There's some little eggs in there, and there are capped cells with some brood in them. And again, nectar is honey. Nectar is pure carbs. It's a really good energy source when you have to fly long distances, but it doesn't have a lot of protein or minerals or the things that growing larvae need to become strong worker bees. And of course, they need water. And I should note that not all nectar is created equal, or I should say all nectar is pretty much created. Not all pollen is created equal. Different plants have different pollen characteristics. So some might have more amino acids, some might have more trace minerals, some might have more vitamins, etc. So just like we do, just like cattle do, these bees are required to have a balanced diet. And that doesn't always happen in domestic colonies. For one thing, we have monoculture. And monoculture is the same pollen all the time for bees. I tell people it's like if you have dairy cattle and you want them to milk really well and you want them to breed, and you give them a really balanced diet, but you only for 3 months of the year give them nothing but corn silage. And then for another 2 months of the year, well, actually, you give them nothing but soybean meal. And then for 5 months of the year, you give them nothing but alfalfa, and the rest. And then the last month of the year, I don't know if that adds up, but the last month they get nothing but supplements with vitamins and minerals and stuff like that. It's a balanced diet, but it doesn't really work for what you want. You're going to have some pretty sick cattle. And it's the same with bees. We expect them to forage on the same pollen for, extended periods of time. And these crops, there's some corn here. These are all taken from near my house. So there's some corn up here. There's some wheat up here. These are wind pollinated predominantly. They're not major bee crops. Here we have some more bee crops. There's a guy that grows bird seeds, sunflower seeds for bird seed around here, which is wonderful. We always drive around town looking for the big sunflower patch. It's great fun. And there's usually a bunch of tourists pulled up along the side of the road to take pictures. This is a Cornell orchard, and you can tell because it says Cornell across the bottom. Cornell orchard actually no longer uses commercial beehives. They only use native pollinators or at least for the past year they did. And they were very successful with that. We also have vineyards, and something else you'll notice in these pictures in particular is there's a lot of stuff underneath the trees and between the vines. And there's some trees and stuff in the background of the sunflowers. These are places where wildflowers can grow. And that adds a little bit of diversity to the diet of both our domesticated pollinators as well as our wild pollinators. But the more we use herbicides, the more we use, products to kill weeds, the more the less diversity these guys are going to have in their diet. So monoculture has been a big challenge for pollinators, I think, and for good reason. The other big challenge for pollinators, I told you that it's the same bees that are pollinating most of the crops in the United States. And this is just a nice picture showing a semi-truck loaded with beehives. So these bees are in a black box. They are hurtling through space at 70 miles per hour till the next next destination. And it turns out that bees also get shipping fever. This is a very stressful time. And if they're going to break with disease, now is a great time to do it. And plus, then when they get to their destination, they're going to be merged with other colonies. So outbreaks are expected at that point. And then there's this big bad guy. This guy is the varroa mite. Look at him. He's sitting on the back of a honeybee. He's tiny, but honeybees are also tiny. So this would be like if you got a tick on you that was the size of a large grapefruit or a pomelo, just feeding on your blood. That's a lot of parasite for a tiny little bee. These came from Asia. They were not in my grandfather's textbook. They were imported to the United States in 1987 when they tried to breed Asian bees with US bees. And it turns out that I should say Apis melliflora, which is which is the European honeybee, which we use in the United States as well. So it turns out that the bees in Asia are very resistant to this. This particular mite specifically attacks drones in Asia. And since the drones have a very limited life cycle, it doesn't really cause much of a problem. But here it attacks the workers and it can shorten their lives significantly. And I'll tell you why that is pretty soon. And there's all these other things as well, but varroa mites are kind of the big bad in the bee industry. And then there's, of course, toxicology. And I've been talking for like a half hour, but toxicology is what I came here to talk about. So I'm going to get to that now. The first major reported honeybee poisoning in the literature occurred in the United States and occurred where? Somerville, South Carolina, Geneva, Illinois, Plymouth, Massachusetts, or Garner, North Carolina. And so I'll give you a few seconds. I will tell you last time I gave this talk, to veterinary students, one of the veterinary students jumped up and said, Geneva, Illinois. And I said, wow, what makes you say that? And she says, Illinois, only bad things come from Illinois, which is kind of disappointing since I'm from Illinois. But it was fun anyway. So I ribbed her for a little while. It was actually Geneva, Illinois. It happened. So there were weevils on a blooming plum tree. They treated the plum tree with Paris green, and Paris green is made out of arsenic. And it is also the paint that was used in Renaissance wallpaper. So when you hear about like Napoleon and people having arsenic in their hair, that was the source of it. It was the Paris green in the wallpaper. Also used as an insecticide. Do not use insecticides in your wallpaper. That's the bottom line for this story. So he sprayed the trees while they were blooming to kill the weevils, and there were dead bees everywhere. So yes, he actually was not so embarrassed by the situation that it prevented him from reporting it. He actually wrote about it in the American Bee Journal, and there you have the information in front of you. The pictures, so this picture is the black and white is a picture from the Little Traveler in downtown Geneva. It's a little cafe. Well, it's the Atrium Cafe at Little Traveler, circa 1921. And then the picture below it is the same cafe. I had lunch there with my mom a couple months ago, so I took that picture. It's still there. And I did go around looking to figure out where this guy, George Thompson, was, where his beehives were. It would have been cool if I could have gotten some soil samples to test for arsenic. I wasn't able to do that. The building with the tarp over it could have been near his property. It could have been a blacksmith's barn. There is a park where his property used to be, as near as I can tell. It was really hard to find information on him. I actually was walking up and down the street looking for older people, but since this happened in the 1800s, there was nobody there that remembered Mr. Thompson. So honeybees have a unique physiology compared to other insects, and that is because honeybees have a symbiotic relationship with plants, and no other insects really, except for our pollinators, really do that. There are herbivorous insects, which are not symbiotic, and plants have limited resources, have limited ability to deal with predation. So, I mean, they can't get up and walk away. So what they do is they produce chemicals that might discourage insects from eating them, or maybe they kill the insects or reduce reproduction or whatever to prevent these herbivores. And of course, those of us who are veterinarians know that some of them will go after mammalian and avian and other herbivores besides insects as well. So that's why plants produce plant phytotoxins. Bees don't worry about that because plants don't want to discourage bees. So the nectar and the pollen are going to be, they do have some phytotoxins in them, but they're not going to be like the rest of the plants, the part that they're trying to discourage herbivores from eating. They want the bees there. So they don't, so these bees never developed the same cytochrome P450s that other animals have. They don't have the same carboxyl esterases, but it's the P450s that we really look at. And of course, some of the P450s are inhibited by insecticides and pesticides. They do have phase 2 conjugation enzymes, just like all of our domestic animals, but they predominantly use glutathione transferase. And then they do have phase 3, which was something kind of you may not be as familiar with if you graduated some time ago. These are basically the transporter molecules. So you think of the ABCB1 mutations in dogs that make them ivermectin sensitive. These are those. These are the phase 3. So in phase 3 enzymes are found in the Malpighian tubules, which are the kidneys, as well as the hindgut and the cuticle. So that's how they move these things out. So where are the phase 1 and 2s? Well, we'll get to that. And this is just a list from a paper I did recently where we summarized what the major and CYP is cytochrome P450 abbreviation, if you're not as familiar with that terminology. And so these are some of the ones you see in insects and what they do. So where is it in honeybees? Well, it turns out that in honeybees, a lot of it is in the fat body, as well as the Malpighian tubules, the kidney, midgut, maybe some in the cuticle and the brain. But the fat bodies are the major source of metabolism in the honeybee. And there's a picture here. The color picture is of the fat body. The greenish stuff, greenish tannish stuff is the fat body itself. And that big pink thing, I'll let you think about a second what that might be, because that isn't supposed to be there. So it turns out that the varroa mite specifically eats the fat body. So not only do you have a giant tick sucking on you, it's eating your liver specifically. This is going to throw all of your toxicology data out the window. Okay. I mean, if you're in liver, you know that if you're in liver failure, you're going to be much more sensitive to a lot of toxicants than you would under normal circumstances. And that's going to be what's going on with these bees as well. And I do want to give credit to Dr. Ramsey, who allowed me to use that photograph. It's his photograph. If you want to learn more about bees, I strongly recommend you look up Dr. Sammy Ramsey. He is a very, very good speaker and a very nice guy. So there are pesticide risk assessment tiers, and one problem with those is they don't account for the parasitism. They don't account for other diseases. Another problem is these were developed based on killing insects individually. They weren't based on keeping social insects alive. So a few bees, if a few bees get poisoned, what does that mean for the entire hive? Probably not much. But if these bees, before they died, brought pesticides into the hive, what does that mean? That might cause significant long-term problems, as in the young, especially since, these insecticides and things can become incorporated into the beeswax and just hang around for years and years. So this is how they do the testing. The field testing is a little bit more close to what we would worry about with a beehive versus an individual LD50. And then there's some modeling applications that are just starting to come out, and they do various different things, but they might be more useful for assessing risks to honeybee colonies, and they might be able to expand that to other pollinators, which would be very, very useful, because we care about our honeybees because they're domestic animals, they're part of agriculture, they're important to us, but so are wild bees, and we haven't cared for them probably as much as we need to. So some of this data might be useful in preventing destruction of those as well. This just shows how bees are exposed, and all the ways you would think of: overspray that can kill a whole hive or much of a hive, at least all the bees that are outside. They can get it, they can go onto pollen, it can go into nectar from overspray. It can migrate through the soil. It can be deposited directly on bees. If a bee flies through overspray, the wings have a lot of surface area and a lot of absorptive capacity, it turns out. They can be in the dewdrops on the plants if it was sprayed, overnight. But what's really interesting is these newer insecticides are called systemic insecticides, and we use those in vet med, so we know what they are, right? These are the products that are a spot on your dog and cat, and they keep the fleas and ticks off for a month. Well, in this case, they put them on the seed coats of when they plant the plants, and it stays in the plant for at least a year, possibly the lifetime of the plant, especially when we're talking about seasonal plants. So that's kind of interesting. And this is just lists of all of the different insecticides that we have looked for. I put the log KOW on here. This is for our toxicology people out there. The log KOW tells you if something's water soluble or lipid soluble. The more lipid soluble it is, the more likely it's going to hang around in wax for a long time. So the cholinesterase inhibitors, they have up to 4.7. That's a high KOW. A lot of it's going to go into the wax. Whereas our neonics, not very much is going into wax. That's less than 1. DDT, 6 to 7. There are samples of wax probably in the United States that still have DDT in them because wax is reused for so long. And some other ones. Piperonal butoxide is really interesting because we found it in almost all of the wax samples in New York. And that is the same thing that's in flea sprays with pyrethrin. It's a synergist. It directly inhibits P450s. So it's in a lot of pesticides. And of course, you're not supposed to spray these when the bees are around, as Mr. George Thompson figured out after he sprayed everything with Paris green. This does not apply to other products. It doesn't apply to fungicides, which can have piperonal butoxide in them, and it doesn't apply to herbicides. Now, if you have fungicides and herbicides on board, if it's in your pollen and nectar and you bring that back to especially the pollen to the hive, how is that going to impact your bee bread, your pollen silage? It's probably not a good thing. And then, of course, overspray I mentioned. This was a case during the last pandemic, Zika virus, where they oversprayed. And this is particularly pertinent to our public health professionals because this is an area where they oversprayed a bunch of beehives. It was early in the morning. It was a really hot day. So all of the HVAC bees were hanging out on the edge of on the surface of the hive, blowing cool air from the morning into the hive so it didn't overheat during the day. I have a house fan. I do the exact same thing. I just turn on the house fan in the middle of August. I turned it on at night, and by morning, the house is pretty cool. That's what these bees were doing when it was oversprayed. So not only did you catch a huge number of workers that were just hanging out at the periphery of the hive anyway to move air, but they were blowing it into the hive. So really unfortunate situation, killed millions of bees. When it happens, it's really striking and it upsets people, but this is not the major toxicology issue with bees. And part of the problem, I think, with this, there are ways that agriculturists can connect with beehives because agriculturists need beehives, right? So they can connect with beekeepers to let them know when they're spraying, to let them know to cover their hives, etc. But this was the public health community during the spraying this time, and the connections weren't there. So when you're dealing with a situation like this, it's something to be aware of. You do not want to kill somebody's bees. So here's a question for you veterinarians out there. Which of these are systemic pesticides when it comes to plants? Is it fipronil, imidacloprid, or spinosad? These all should be fairly familiar to you if you do any dog and cat work at all. And I'll just give a second while I drink a sip of water. So I'm going to say, and everybody's on top of this, just like our insecticides that we use on cats and dogs, these are all systemic. And you guys all knew that. So systemic insecticides present a unique issue because they are present in nectar and pollen. And nectar and pollen generally don't contain phytotoxins. So that's the specific thing that bees eat. That's why we worry about neonics in these guys. And there hasn't been much data on spinosad yet. I have concerns. Fipronil and the neonics seem to be a major issue that these guys are exposed to at low levels constantly. And you know, they've looked at, this is older data, it's not specific to neonics, but they looked at the number of pesticides in bees from different areas. And you can see in agricultural areas, there is quite a bit of pesticide found in these guys. Maybe a little bit less in urban areas, although urban areas have their own issues. I don't talk very much most of the day. I will start next semester, but my throat's getting a little scratchy. So these are all the neonics. They have very low mammalian toxicity. We have different nicotinic receptors than insects do, which is wonderful. So these are virtually non-toxic to us. However, they're not great for bees. There are movements afoot to minimize these for use in small animals because of the pollinator risk. I'm not sure there has enough data to support that these are really causing a risk to pollinators. So it'll be interesting to see how that plays out. So what do these things do short-term or long-term low exposure? Well, they decrease mitochondrial function, which might make it difficult to fly for 2 miles to find a place full of, to collect supplies to pollinate plants. They affect learning and memory. So you might be able to find the plants, but can you find your way back to the hive? And if you can find your way back to the hive, can you tell the other workers where you found the plants? That's pretty important. You know, half of the work is finding the plants, and the other half is telling everybody this is where you need to go to pollinate plants. It impacts brood production and survival. And remember, the pollen from these things is converted into royal jelly by the nurse bees and then fed to the larvae. The same wax is used over and over again. And 1 year it might be brood wax, and 1 year it might be honey wax. So, and 1 year it might be bee bed wax. So all those contaminants have multiple ways of reaching the larvae. And it causes decreased grooming. And who cares about that? Well, it turns out that's how bees remove parasites like varroa mites. So it might actually make them more susceptible to varroa infection, which in turn makes them more susceptible to toxicants. Spinosad, we don't have too much information yet. It is similar to nicotinics in its mechanism of action, low mammalian toxicity. But the main issue is with this one is it is allowed for organic farming. So you can't use neonics in organic farms, but you can use these. So there are places to report bee kills if you suspect one. Here's the EPA's website. There are limited diagnostic opportunities if you suspect poisoning in bees. Cornell, we're working on it. We can definitely test. Well, we're working on testing wax for pesticides. We can definitely test it for like mineral contaminants, heavy metals, lead, mercury, things like that. And of course, the pesticides can accumulate in different areas of the hive. So I gave you those KOWs that you probably don't care about, but high KOW more likely to be in wax. So that's something like DDT. Low KOW more likely to be in nectar and honey. So that's where your neonics are going to go. And this is my beautiful picture. So I finished my MPH last year at Cornell, and I am officially inbred now. as a Cornell faculty member and graduate. And one of the things they taught us, like I spent 5 years learning, yes, I was a slow MPH student. Thankfully, I didn't quit my day job, but I spent 5 years learning how to make pretty graphics. So this is my first published pretty graphic. And it basically just gives you some information on, things to consider when collecting samples for toxicology testing. And if this is a potential legal case, which in the case of an overspray, it very well may be, it could be really important to do a chain of custody sheet on these. Now, one of my co-authors on one of the last papers published this as well. Dr. McCart had done some work on antitoxins. So basically, he made these little things that are about the size of a grain of pollen, and on the outside, it's kind of glycerol and calcium carbonate, and it digests in the stomach of the bee, in the foregut, and then it releases a binder that binds up to a specific organophosphorus insecticide. And it works great. They did the studies, and if you gave, I think it was methomyl, and if you gave the bees methomyl straight up, they all died. And if you gave them this before you gave them the methomyl, they all survived. I mean, it was like 0 versus 100% survival. So it's pretty useful in that particular situation, but it's only for one chemical. And there are thousands of chemicals out there, and they're not used singly, they're used in cocktails. So bees are being exposed to lots and lots of things at once. And also there's toxic plants. So which of these plants is toxic to bees? I'm not going to spend a whole lot of time, but there's the California buckeye, the yellow star thistle. Remember, a California buckeye causes the buckeyes in general, I'm not sure about California, cause a paresis in animals that ingest them. Yellow star thistle causes equine disease, similar to Parkinson's. Chives cause hemolysis in dogs and cats, and lantana, which causes liver failure. So people are thinking this one over. This is a toughie. I'm getting lots of different answers, but I am going to cut it a little bit short. And it turns out that it's the California buckeye. It causes a paralytic disease in bees. I don't know of any toxicosis associated with the others in bees. There's also one in California called leatherwood that causes purple brood. This was in my grandfather's book. And that's actually where I first read it. It was really hard to find more details about it. But if the bees pollinate this plant, the larvae develop purple guts and die. So it's called purple brood disease. Buckeye causes bee paralysis. I have not found anything about like Ohio buckeyes or horse chestnuts doing this, but I would wonder about it. Milkweed is sticky. So the milkweed pollen is made to stick to pollinators, and it's so sticky that they can become entrapped later on. So you see this bee stuck to a milkweed leaf. Jasmine, Gelsemium, contains an alkaloid very similar to strychnine, and it can cause worker and bee and brood deaths. And then Veratrum californicum. I think I'm trying to remember what exactly that causes in bees, but it is definitely toxic in bees, and my slide has reformatted itself, unfortunately, to cut that out. Then you see other toxic plants that produce toxins that may or may not be toxic to bees. In fact, it turns out that tobacco, the nicotinics in tobacco actually enhance development of bee brood. So it actually makes bee brood stronger. But these can all be present in honey. So if your bees are pollinating tobacco, you will have nicotine in your honey. You can have aconite if they're pollinating monkshood. If you're pollinating a pure lysine alkaloid plant like comfrey or senecio or crotalaria, you can have those in your honey. And those in animals cause liver failure. In humans, they cause pulmonary vascular disease. Now, the rhododendrons and related are a special case. They are producing what's called mad honey. What is mad honey? It is honey that makes your mouth all numb. And people want this. But the cool thing about mad honey to me is Mithridates, who was an early experimental toxicologist. He was actually the king of Pontus, and he went to war with Rome. He came up against the general Pompey, and he knew that he didn't have adequate forces to hold the town that they were holding. So he had his people abandon the town, but before they left jars of honey and loaves of bread. So the Roman soldiers came in and thought they had it made because they were hungry and they were tired, and there was honey and bread everywhere. And when they started eating it, it gave them a gastroenteritis that was not funny, and it also made their hearts palpitate because that's what rhododendron toxins do. It's grayanotoxin, it's cardiotoxic and GI toxic. So while they were puking their guts out and fainting, Mithridates brought his army back in and basically slaughtered them en masse. He did not win the war, but he certainly won that battle. So that is the story of mad honey. There are several plants. The heartbreak grass, Gelsemium, also contains a strychnine-like alkaloid. Poppies, of course, can contain opioids, so don't take a drug test if your honey was pollinated on poppies. But the tutu is an Australian plant that has caused severe poisonings in people that have ingested honey, as has the Triptergium. I'm more comfortable pronouncing the Latin name than the Chinese name, but the Triptergium has caused severe poisonings in China. And people have not been killed by these, but they were pretty sick. And without medical attention, they may not have survived. So I mentioned all of these, the pyrrolizidine alkaloids, the gelsemine. There are heavy metals in industrial areas. And then, of course, honey, the beehive is a really good place for aspergillus to grow. So you can see aflatoxins and ochratoxins in honey as well. And just showing this is, this is my kitchen window. And you can see on the inside that I'm a terrible housekeeper, and on the outside that I have a lot of chippy paint. It's an 1850 circa house. There is lead paint there. If a pollinator lands on that, they're going to pick some up. There is going to be a small amount of lead in the plants that are landscaping my area. So these are ways that bees can become exposed to these as well. You all are probably pretty familiar with selenium. There is potential for selenium uptake in bees as well. Colony collapse disorder. I'm not going to spend too much time on this. This may have been a viral disease. It's kind of worked its way out of the system. It's not very common right now, but in 2006, it was definitely a big concern. The interesting thing in this particular case was that when hives were hit with colony collapse, all the bees vanished. So you would go out to the hive and there'd be a few nurses and workers and the queen and nothing else. So they couldn't support, you can't support a hive without workers. And, these hives would just die very soon after. And it appears that it was a behavioral protective mechanism, because when bees are very sick, they do leave the hive to prevent spreading disease. So that seems to be what went on with these. I don't think I have time to talk about the buzz of Technicolor honey, but it's a pretty, or at least not in depth, I'll kind of touch on it. There have been a few cases where honey was not the right color. And it might be Robitussin red, as it occurred in New York, or it could be green and blue, which is what happened in Paris. And the reasoning for this was where the bees were foraging. And this just shows you what colors they were. And in New York, you can look this up in the New Yorker. It's, I think, free to read the article at this point in time. It's very old. This was a very tragic story indeed about a maraschino cherry factory. It turns out that the bees were getting to the maraschino cherry factory and getting the food coloring and bringing that back to the hive. Well, the FDA does not want your business, if you are in a food manufacturing business, to have insects coming and going, as you might imagine. So they inspected and they noticed that there's a back wall and bees were coming and going behind the back wall. And so the question was, and then so they went to the other side and they noticed that the back wall inside the plant was several feet away from the back wall outside of the plant. So they knew there was a false wall in there. There was something going on. They told the owner that they were gonna basically take down the fake wall to see what was behind it. He said, please don't. They said, we're the FDA, we can do it if we want to, we have to. You will note that this was some time, more than 10 years ago, 2013 it says, and it probably happened, it happened sometime before that as well. So the owner of the maraschino cherry plant, when the FDA people left his office, he reached into his drawer and then walked into the bathroom behind his office and shot himself in the head. When they pulled down the wall, it turned out that there was a marijuana plantation back there. And at that time, we had the Rockefeller laws in New York, and he knew that he was going to go to prison for the rest of his life if he survived the incident, which he did not. So that was one story. And in Paris, it was the fact that the M&M factory was very near the beekeeper, and they had a big compost pile out back, so that the bees weren't getting into the M&M plant, but they were eating the candy shells and bringing the sugar back. I will note that these sugars are not that the honey made from these is pretty, but it's not delicious. So it was kind of fun as a novelty item, but you wouldn't want to put it on your toast. It just didn't have the right flavor. It didn't have the right texture. And so awesome resources. Dr. Terry Ryan Kane finally published her book this year on honeybee medicine for the veterinary practitioner, and that's the US-based book. Vidal Naquet had produced the European book, and there was a nice cast commentary on bee health a few years ago. AVMA put out its guide, and then Johnson has actually done several publications on honeybee toxicology, which are really excellent. JVDI, Journal of Veterinary Diagnostic Investigation, for November of 2023 was the honeybee issue. And I have not gotten my paper copy, and I'm kind of annoyed at that, but it's definitely available online, so you can read more about honeybees there. And it doesn't look like there's a lot of questions, which is good because I ran over time, but I am still here and happy to discuss. And I would say to Michelle, Dr. Willett, that I can give you my slides. I can also give you, I have a summary that I gave to some students recently, and there's also the JVDI paper on honeybee medicine for diagnostic toxicologists that came out last month that I can supply you with if you're interested.
All right. Somebody did ask a question in the chat. Can you comment on the use of honeybees as biomonitors for monitoring antimicrobial resistance in the environment?
That is a really good question, and I've only read a couple papers that were on that. And it turns out that they do use antibiotics on some crops, and in particular Florida oranges. So that's kind of outside of other regulations for medical uses. So that's a really interesting issue. And I'm trying to think, we actually have the ability to test for certain antibiotics. It's not something we've been looking for in our lab at this point in time, but we do have that capability. So it might be something that would be worth adding to our testing. Although, like I said, right now, most of the work I think has been, and I haven't specifically looked up AMR in bees, I'll put that out there, but I think a lot of the work so far has been done on antibiotics that were specifically used on crops by agriculturists at this point, not on, feedlot or anything like that. Although there has been proposed that manure runoff might be a significant contamination issue for certain pesticides in bees.
There is a question in the Q&A. There is a general insect decline, it seems. What do you think we in the animal world are facing generally because of this circumstance?
Well, I know it's extremely, extremely expensive for agriculturalists to deal with pollinator declines. The problem, and there are certain places in the world, in parts of the Himalayas, where the pollinators are basically gone and people are actually hand pollinating crops, from what I've heard. It's a major, I mean, it causes increased, increased work requirements, increased labor, and that's going to increase the costs for producers, and it's going to lower their income. Monoculture is a huge threat to pollinators, and we haven't reached the point where it's a bigger threat to pollinators than it is where the costs of the threat to pollinators have exceeded the costs of polyculture. So that's why that's not really happening as far as I know. But I think, so the question is, do you think, what are we facing generally? We're facing more expensive produce. We're facing declines in certain bee pollinated crops. We're facing declines in wildflowers, weeds, things like that that we may not like, but that support wildlife. So it's not just our domestic animals and us that are at risk. It's a lot of other species that are at risk at this point. So those are all very concerning things. What can we do about it? I think we need to we're going to need at some point to shift from monoculture to polyculture, so that it has so many other benefits besides protecting pollinators. You're public health people, you know that when you have a whole bunch of the same species in one room and a disease breaks out, it's going to spread like wildfire. So when you have polyculture, you're going to have slower disease spread within your crops. You're going to need less pesticides. You're going to need less herbicides. You're going to need less of all of those things. So in the long run, that is basically what we need to move to.
Someone has asked in the chat, is there anyone looking at pesticides, herbicides, antibiotics present in honey?
There absolutely is. It's something that my lab is going to get involved in once we get the wax. So there are different labs that are doing honey, wax, and bee larvae, pollen. You can do the pollen from bee bread, and there are actually ways to do pollen that is coming into the hive so that you can get a real-time measure of what the bees are being exposed to. There are little pollen traps that you can put on your hive so that when the bees come in, it knocks some of the pollen off of their little legs, and you can use that for testing. So these are all things that are possible. They are being done to some extent. And from a toxicology point of view, it really does make a lot of sense to test multiple substrates, because I showed you that the reason I showed you that KOW, we know that DDT and organochlorine and organophosphate insecticides and pyrethroids are going to be in the wax, but we also know that neonics are going to be in the honey because they're water soluble, whereas the others are fat soluble. So there's a need for all of this kind of testing, and some of it is in fact being done. So that's a good thing to look for in the future. And fingers crossed, my lab will be doing honey pretty soon. Unfortunately, right now we're only doing wax. So when the wax samples come in full of honey, I have to suck all the honey out of the wax before we can test it. It's a tough job, but somebody's got to do it. My toast appreciates it.
All right, excellent. All right, fantastic. Again, Dr. Bischoff, we definitely appreciate your time and expertise, and we can't do these webinars without wonderful volunteers like Dr. Bischoff.
And I'm actually going to throw one more thing out there. I know Dr. Kane always does a lot of beekeeping stuff at AVMA meetings. So if anybody goes to those, definitely recommend. I know it probably a lot of, yeah, I don't know how many people from this group would do that. I know a lot of the state veterinarians go to USAHA, but.
All right, I'm going to close out today. I appreciate it. And if anybody is interested in providing a webinar for our webinar series, again, we can't do this without wonderful volunteers like Dr. Bischoff. And if you are interested, just please email me at admin, ADMIN, @acvpm.org. We'll get you in touch with the Continuing Education Committee, and we can get you on the schedule. For those people that are ACVPM diplomates and are subject to the Maintenance of Certification program, Providing a webinar does provide continuing or maintenance of certification points. So it's kind of a win-win for everybody. So again, I thank you, Dr. Bischoff. I thank everyone for their time as they attended today's webinar. And our next webinar is scheduled for the 14th of December. And the topic is the in-bath. So I appreciate everybody's time. Thanks. Have a great evening.